Welcome to EPG Pathshala, a gateway to online postgraduate courses. In this module, we are going to talk about data communication networks. Data communication refers to transmission of digital data between two or more computers. These communicating devices are interconnected through data networks. The physical interconnection between these network computing devices can be established through either wired or wireless transmission media. We are living in information age. The extensive research and development in the field of data communication and networking has caused the development of new technologies that has revolutionized data communication across the globe in a way that had never been possible before. Previously, in order to transmit an information, it used to take hours and days. Now, huge amount of information can be transmitted within few seconds, thanks to our high-speed data networks that have enabled people to connect across the globe without any hassle and almost instantaneously, irrespective of their physical location. The first data communication network can be thought of as the telegraphic machine demonstrated by Samuel P. Morse in the year 1844. The best example of data communication is Internet. Internet is anywhere and everywhere. Virtually, all the computers are interconnected. By the virtue of Internet, we can have access to all the information across the world sitting at our home. So, all the information is just a click away. So, let us venture into the world of data communication. This module will let you through the basics of data communication system. The basic learning objectives of this module are: understand the concept of data communication system, to learn the various data codes and their representation, to understand the various data transmission modes, to know about different types of data communication standard organizations. So, how do we define data communication? Data communication refers to the exchange of data between two or more devices through suitable transmission media, either wired or wireless. It permits the transfer of binary or digital information between remote computers. Almost any type of data can be digitized. The effectiveness, low cost, reliability, and high speed of digital technology have made data communication more widespread and inevitable in today's world. One of the major applications of data communication is Internet, linking billions of devices worldwide, and through which we have the access to extensive range of information and resources at our fingertips. One of the other applications is electronic mail or email. This enables us to send data from our personal computer to anyone anywhere in this world and receive information from anyone across the globe. Let us now have a look at the basic components of data communication system. The system has 5 major components. The first one is message. Message is the information data that is intended to be communicated. Information data can be in the form of text, numbers, image, audio, and video. Sender. The device that sends the data information is called as the sender or transmitter. Sender can be a computer, workstation, telephone handset, video camera, mobile phone, and other peripheral devices. Transmission media. The physical path through which data is transmitted or sent from the sender to the receiver. It is also known as communication channel. Transmission medium can be wired like twisted pair wire, coaxial cable, fiber optic cable, or telephone line, etc. Or it can be wireless over the free space using radio, microwave, and infrared signal. Receiver. The device that receives the data information from the sender is called as the receiver. It is also known as a sink. A receiver may be a computer, workstation, telephone handset, mobile phone, television set, printer, fax machines, and so on. The last and the most important element of data communication system is protocol. Protocol is a set of rules that governs the data communication. It refers to the agreement between the communicating devices. It defines the procedures the devices will use during the process of communication. Without a proper protocol, the devices may be connected, but they cannot communicate with each other. Numerous protocols are being used to provide the networking capabilities, specifying the data rate, the flow control, the data segmentation, assembly, sequence control, error detection, and control. Now we introduce the concept of data codes and mention the different types of data codes used in data communication network to transmit information from source to destination. Data is communicated between computers as sequence of binary digits or bits. Data codes refer to the way in which bits are grouped together to represent different symbols. A sequence of bits are grouped to form a data character, and an encoding scheme translates each group of bits into a character. Hence, a unique binary code for every possible character to be communicated is generated and stored in the computer. The two communicating devices must use the same code in order to communicate properly. There are a number of different codes, but the most common code in use today is the ASCII code. Now, when we have known about the definition of data codes, let us discuss the different types of data codes. Majorly, there are 4 types. Morse code. In 1844, Samuel F.B. Morse successfully demonstrated an electrical telegraph system. The transmitting end of the telegraph system sent text information in the form of electrical pulses along wires which control the electromagnet at the receiving end. Morse developed a special code called Morse code to transmit and receive messages at high speeds up to 80 words per minute. Morse code is a series of dots and dashes representing alphabets, numbers, and punctuation marks. Dot and dash are usually represented as a short electrical pulse and a long electrical pulse respectively. The telegraph key, when depressed, causes current flow in an electromagnetic coil that attracts the armature and releases it quickly when the current stops making clicks during both the instances. When the armature is closed for a short duration, a dot is produced, and when closed for longer time, a dash is produced. The transmitter switches the carrier signal on and off to produce dot and dashes. The table in the slide displays Morse telegraph code. As we can see, alphabet A is represented by a single dot and single dash. Alphabet B is represented by single dash and 3 dots, and so on. The next code is Baudot code. The Baudot code was developed by a French engineer, Thomas Mouret, in the year 1875. He named the code after the pioneer in telegraph printing, Emile Baudot. It was used extensively in early teletype machines, which was like a typewriter, and was used to send and receive coded signal over a communication link. Pressing a key on the typewriter keyboard generates a unique code which is further transmitted to the receiving machine that prints the corresponding character. It is recognized as the first fixed-length character code for machines. Baudot code is a 5-bit code representing 32 different characters. In order to accommodate 26 letters of the alphabet, 10 numbers, and various punctuation marks, it uses 2 shift codes, letter shift code and figure shift code. 2 of the 32 combinations were used to select the shift codes. if the message is preceded by the letter shift code, which is 11011, all of the following codes are interpreted as alphabet letters. When preceded by the figure shift code 11111, all the following characters are interpreted as numbers or punctuation marks. For example, if we have 01001 preceded by letter shift code 11011, the character is interpreted as alphabet L, and the same binary bit combination when preceded by the figure shift code 11111 is interpreted as a right or closing parenthesis. The next data code is the most widely used data communication code, known as the American Standard Code for Information Interchange, or ASCII. The ASCII code was developed by a committee of the American National Standards Institute (ANSI) for binary data coding. ASCII code is a 7-bit code representing 128 alphanumeric symbols with a distinctive code word. The least significant bit is designated as bit 0 and the most significant bit is designated as bit 1. The first 3 bits from MSB onwards indicate whether a number, letter or character is being specified. The first 32 values, character code 0 to 31, are non-printing control characters such as NUL, which stands for null character, STX for start of text, ETX for end of text, LF line feed, DLE data link escape, US unit separator, CR carriage return, file separator, FS, GS for group separator, CAN for cancel, SUB for substitute, ESC for escape, etc. Most of these are used to control peripherals such as printer. All these can be visualized from the table displayed in the slide. Codes 32 to 127 are common for all the different variations of the ASCII table. They are called printable characters, representing letters, digits, punctuation marks, and a few miscellaneous symbols. Almost every character can be found on the computer keyboard. The advantage of ASCII code is its ability to represent both upper and lowercase letters of the alphabet. For 8-bit data, the 8th bit, which is not the part of ASCII code but is reserved for parity bit required in error detection scheme. Character 127 represent the command DEL, which stands for delete. The next type of data code is EBCDIC code. EBCDIC stands for Extended Binary Coded Decimal Interchange Code. It is an 8-bit alphanumeric code developed by International Business Machine, IBM. It was used in IBM computers and IBM compatible equipments. There are 4 main blocks in the EBCDIC code page: 0000, 0000 to 0011, 1111 is reserved for control characters. 0100, 0000 to 0111, 1111 are for punctuation. 1000, 0000 to 1011, 1111 represents lowercase characters, and 1100, 0000 to 1111, 1111 for uppercase characters and numbers. EBCDIC code allows a representation of maximum of 256 characters. EBCDIC has a wider range of control characters than ASCII. The major disadvantage of this code is that parity checking for error detection cannot be used on 8-bit system. Most other computers use ASCII code. Now let us learn about the various ways of representing data. Data can be represented in various forms such as audio. It refers to the transmission of sound or music. Audio signal is a continuous signal representing sound as an electrical voltage with the frequency range of roughly 20 to 20,000 Hz. Audio signals may be directly synthesized or may be originating at a transducer such as a microphone, musical instrument, pickup or tape head. Video. This word originates from Latin meaning I see. Video refers to recording and transmission of image or movie. Video, when captured by the TV camera, is produced as a continuous entity. It is a discrete entity when is in the form of series of images processed in rapid succession, creating the illusion of motion. Numbers. Normally, we write numbers using digits 0 to 9. This is called decimal number system with a base of 10. However, any integer can be easily represented by a sequence of zeros and ones known as binary numbers. Numbers are represented using binary number system. ASCII is not used to represent numbers. Text. Text can be represented easily by assigning a unique numerical value for each symbol used in the text. For example, the widely used ASCII code defines 128 different symbols. All of these characters you may find it on standard keyboard, and assigns to each unique numeric code between 0 and 127. When you save a file as plain text, it is stored using ASCII. The code value for any character can be converted to base 2, so any written message made up of ASCII characters can be converted to a string of 0 and 1s. Images. Image comprises of matrix of picture elements known as pixels. Each pixel is a tiny dot of color which collectively create an image. Greater number of pixels on the screen yields higher resolution, enabling finer detail representation. A color is typically represented by 3 component intensities such as red, green and blue. Some combination of these 3 color components is represented by a pixel. Now let us learn about the different types of data transmission mode. Data transmission refers to the movement of data bits along the transmission media connecting to 2 devices. Data transmission between 2 connected devices can be in various ways. The transmission can be characterized by number 1, the direction of data exchanges, second, the number of data bits sent simultaneously, third, the synchronization between the transmitter and the receiver. The data transmission mode based on the direction of exchange are simplex, half duplex, full duplex. In simplex communication networks, communication can take place in one direction only. Connected to such a circuit are either a send-only or receive-only device. The transmitter and the receiver operate on the same frequency. Simplex transmission generally involves dedicated circuits. It is not possible to send back error or control signals to the transmit end through simplex channels. As shown in the figure, A transmits and B receives. The direction of data signal is only in one direction, that is from A to B. This way of communication can also be called as unidirectional or one-way communication. Simplex circuits are analogous to escalators, doorbells, fire alarms and security systems. Let us now see some of the examples of simplex communication. A communication between a computer and a keyboard involves simplex transmission. The CPU never needs to send characters to the keyboard, but the keyboard always sends characters to the CPU. Other simplex devices could be the monitor that can only accept output. A television broadcast is also a simplex transmission. Other example of simplex transmission is loudspeaker system. An announcer talks into a microphone and his or her voice is sent through an amplifier and then to all the speakers. Signal travels in only one direction from microphone to speaker. Half duplex. A half duplex system can transmit data in both directions but only in one direction at a time. That means half duplex mode support two-way traffic but in only one direction at a time. Both the connected devices can transmit and receive but not simultaneously. When one device is sending, the other can only receive and vice versa. As seen in the figure, when A is in transmit mode, B is in receive mode and vice versa, it is possible to perform error detection and request the sender to retransmit information that arrived corrupted. Two existing stations alternately, not simultaneously, send signals to each other on the same frequency. This type of connection makes it possible to have bidirectional communications using the full capacity of the line. The only advantage that half duplex is that the single connection is cheaper than the double connection. This way of communication can also be called as non-simultaneous bidirectional communication. Some examples of half duplex communication: a walkie-talkie system. It can only send or receive a transmission at any given time. It cannot do both at the same time. A walkie-talkie requires only a single frequency for bidirectional communication. Communication between the computer and the line printer is half duplex. Printers send messages to the computer. The printer cannot send these messages while the computer is sending characters, but when the computer stops sending characters, then the printer can send messages back. Full duplex. A full duplex system can transmit data simultaneously in both directions on transmission path. Both the connected devices can transmit and receive at the same time. Therefore, it represents truly bidirectional system. Here, as shown in figure, A and B can simultaneously send and receive data. The communication link may contain two separate transmission paths, one for sending and another for receiving. Most of the data networks are using duplex transmission, using different channels in the same medium, connecting the transmitter and receiver. Each of the channels is half duplex, but together it makes a full duplex system. This type of transmission can also be called bidirectional transmission. The use of full duplex increases the data transmission rate. Modern network interface cards are configured for full duplex support by default. Full duplex transmission, the channel capacity is shared by both communicating devices at all times. The best example of full duplex communication are the telephone networks. When two persons talk on telephone line, both can listen and speak simultaneously. The transmission mode can be characterized by the number of elementary units of information or bits that can be simultaneously translated by the communication channel. Based on this, the two types of transmission modes are parallel transmission, serial transmission. In parallel data transmission, all data bits are transferred simultaneously. Parallel data transmission is extremely fast, can be of the order of nanoseconds, since there is a simultaneous transfer of all the data bits. The transmission speed is limited to the speed of the logic circuits involved in the data transfer. Parallel data transmission is not practical for long distance communication, as multiple wires cost more than a single wire, and it also suffers signal attenuation. In fact, computers never process a single bit at a time. Generally, they are able to process several, and for this reason, the basic connection on a computer are parallel connections. As shown in figure, a register is loaded with n-bit binary word that needs to be transmitted. The register contains one flip-flop for each bit. All the flip-flop outputs are connected to transmission lines that carries the data bits to the receiver. The receiver has also n-bit storage register. In parallel data communication, you need one wire for transmission of each data bit. Therefore, there is a necessity of multi-wire cable. When a clock pulse is applied to the flip-flops of the register, the bits of the word are transmitted simultaneously during the time period of a single clock pulse. Serial transmission. In serial transmission, data bits are sent sequentially, that is one after the other, on the same channel or wire. It reduces the cost for wire but slows down the speed of transmission. In computers, digital data transmission between circuits is in parallel format. Therefore, parallel to serial conversion devices are required at interface between the transmitter and the single transmission line. Also, there is a requirement of serial to parallel conversion between the single transmission line and the receiver. Such data conversions are made possible by shift registers. When a clock pulse is applied to the sequentially cascaded flip-flops of the shift register, the bits of the word are shifted from one flip-flop to the next. At the end of n clock pulses, all the n data bits of the word will be transmitted. The transmitted serial word over the communication link is then received by the serial in parallel out shift register at the receiving end. Further, the parallel data outputs from the shift register is transferred to the computer circuits. Now we discuss about the transmission modes based on the synchronization between receiver and transmitter. They are namely classified as asynchronous data transmission and synchronous data transmission. Asynchronous data communication. Each data word representing single character has a start bit before the byte and stop bit at the end of the byte for start or stop synchronization or identifying the beginning and ending of the word. When there is no information being transmitted, communication line is at high state, which is binary 1 referred to as mark. Start bit is always 1 bit duration and is always equal to binary 0 referred to as a space. The transition from mark to space indicates the data word beginning and aids in receiver synchronization. Stop bit may be 1 or 2 bits duration and is always equal to binary 1 or mark indicating the end of word. The start and stop bits ensure the transmitter and receiver synchronization. It is extremely reliable communication mode but bit slow due to significant overhead caused by the addition of start and stop bits per character transmission and is inefficient when large blocks and volume of data needs to be transmitted. Synchronous data transmission. No start or stop bits. Continuous block of data of multi-words are transmitted. Synchronization between the transmitter and the receiver is maintained by means of group of synchronization bits both at the beginning and ending of the data block. Each of these data blocks may contain hundreds and thousands of characters. These blocks are encapsulated with header and trailer along with flags. As shown in the figure, 2-bit synchronization characters indicate the start of data transmission. The end of the data block is specified by another special code ETX. ETX stands for end of text. ETX is usually followed by one or more error detection code. Since the number of synchronization bits used in synchronous transmission is much less as compared to the number of start and stop bits used in a synchronous transmission per block. It is much faster than a synchronous transmission. Now, let us learn the different types of standard organizations for data communication. An association of organizations, governments, manufacturers, and users form the standards organization. They are responsible for developing, coordinating, and maintaining the standards. All the data communication equipment, manufacturers, and users should comply with these standards. The major standard organizations for data communication are International Standard Organization (ISO), International Telecommunications Union Telecommunication Sector (ITUT), Institute of Electrical and Electronics Engineers (IEEE), American National Standards Institute (ANSI), Electronics Industry Association (EIA), Internet Engineering Task Force (IETF), Internet Research Task Force (IRTF), Telecommunications Industry Association (TIA), Internet Architecture Board (IAB). To summarize, in this module, we have learned about the basics of data communication. We learned the definition of data communication. We learned the different elements of data communication system. We learned about the different data codes, which are as follows: the Morse code, Baudot code, ASCII code, EBCDIC code. Then we learned about the different way to represent data. Data, as we know, can be represented by text, image, video, audio, or numbers. Ahead, we studied about the different types of data transmission modes depending on the direction of data exchange, depending on the number of data bits sent simultaneously, depending on the synchronization between the transmitter and the receiver. And at the end, we learned about the different types of standard organization for data communication.